Commercial cell. A lead storage cell, a dry cell, a nickel-cadmium cell, etc. are some of the commercial cells. They can be classified into two categories. 1. Cells which become dead after a long use and cannot be recharged. These cells are known as the primary cells. 2. Cells which become dead after a long use but can be regenerated and can be used again. Such cells are called secondary cells. A dry cell is a primary cell, but a lead storage cell, nickel-cadmium cell, etc. are secondary cells. One, a dry cell. This cell consists of a cylindrical container having a closed bottom. It is made up of a zinc sheet. A porous thin paper lining is provided on the interior of this container. A graphite rod is held in a vertical position at the center of the container. This rod does not touch the bottom. A small quantity of MnO2 is kept in the surrounding of the rod, and the rest of the cylinder is filled with a paste of ZnCl2 and NH4Cl. The mouth of the cylinder is sealed with special wax. A small portion of the graphite rod remains above the seal. The outside surface of the cylinder is covered by a thick paper. When the cylinder and the graphite rod are connected by a conducting wire, zinc acts as an anode and the graphite rod, which is in contact with MnO2, acts as a cathode. The following reactions occur at the electrodes when the cell operates. At anode, Zn solid gives plus Zn2 plus 2E minus. At the cathode, 2MnO2 plus 2NH4 plus 2E minus gives is equal to Mn2O3 plus 2NH3 plus H2O. However, the actual reaction occurring at the cathode depends on the duration of continuous use of a cell and the period between two successive uses of the cell. The potential of this cell is nearly 1.5 volts. As Mn3 cannot be oxidized to Mn4 by reversing the direction of the current, the cell cannot be recharged once it becomes dead. This kind of a dry cell was first prepared in 1867 by Leclanche in France. Therefore, it is also known as a Leclanche cell.